Operation IceBridge. You may know it from the beautiful photos that pop up in your feed. But did you know that IceBridge is the largest polar airborne survey of its kind? IceBridge was designed to study annual changes in the thickness of sea ice, glaciers, and ice sheets, as well as bridge the data gap between the ISAT and ISAT-2 polar observing satellites. Between 2009 and 2019, IceBridge flew over 1,000 scientific missions, gathering data that has redefined our understanding of the cryosphere. So let's take a look back at some of the mission milestones from over the years. One of the first steps to measure sea ice thickness is to get a handle on the amount of snow that accumulates on top of it. The IceBridge team pioneered the use of a snow radar instrument to gather the first widespread data set of snow thickness on top of both Arctic and Antarctic sea ice. Closer to land, the point at which a glacier begins to float is called a grounding line, and it's a very challenging place to measure ice thickness. Using two instruments, a radar sounder and a gravimeter, the IceBridge team was able to survey hundreds of these complex transition zones, enhancing scientists' understanding of the rapid changes in glacier behavior. In 2011, NASA scientists discovered a 19-mile-long crack across the Pine Island Glacier, one of the fastest retreating glaciers in Antarctica. The crack measured 260 feet wide and 195 feet deep when it was observed. Throughout the mission, IceBridge was able to map rifts in ice shelves prior to major calving events. And while these events are part of a natural cycle, IceBridge's observations helped scientists better record the changes in calving frequency and model how they may be related to a thinning ice shelf. The motion of the Antarctic ice sheet, the largest ice sheet in the world, is heavily influenced by the topography of the bedrock underneath. In 2013, the British Antarctic Survey used over 25 million measurements collected by IceBridge and other projects to develop a 3D map of Antarctica's bedrock topography. Called BedMap 2, it provided unprecedented detail of how the continent's bedrock shaped the flow of the ice sheet. Data collected by IceBridge enabled many discoveries in the Arctic as well. A team from the University of Bristol used IceBridge's radar data along with other data sets to uncover a 400-mile-long canyon buried under nearly 2 miles of ice. This hidden canyon is longer than any other known on Earth and provides a critical clue to modeling how melting ice is funneled into the Arctic Ocean. Using ice-penetrating radar data collected by IceBridge, scientists were able to build the first ever age map of the layers deep inside the Greenland ice sheet. For the first time, scientists can navigate the history of Greenland's ice layers, extending previously collected ice cores to better understand the ice sheet's history and help build models of its future. An international team of scientists used decades of NASA data to uncover a massive impact crater hiding beneath the Hiawatha Glacier in northwest Greenland. At roughly 1,000 feet deep and more than 19 miles wide, it is potentially one of the youngest large impact craters on Earth.
6. That's gonna 5, 4, 3, 2, 1. Mark on the overpass 0435 350.
Ice was bridged on April 8, 2019, with the direct underflight of the ISAT-2 satellite over Arctic sea ice. For the first time, both ISAT-2 and IceBridge would be taking the same elevation measurements over the same ice. These mirrored measurements were critical in validating the satellite's instruments and continue the legacy of IceBridge after the mission was completed. Over the course of its 11-year mission, IceBridge completed 1,056 scientific flights and provided a wellspring of data that fueled the publication of more than 660 papers and counting. The mission provided new insight into the processes driving the changes in the cryosphere, helping scientists better understand what we can expect in the future.